This demonstration will illustrate the variable speed capabilities and energy efficiency of the Greenheck Vari-Green motor. It will also compare the performance of the Vari-Green motor to another technology, the PSC, or Permanent Split Capacitor motor with a speed controller. Our demonstration setup is very simple, consisting of two model G101 fans with identical 1/4 horsepower operating loads. The fan on the left is equipped with a Vari-Green motor and a simple 0 to 10 volt dial for fan speed control. The fan on the right has a PSC motor and common rheostat type speed controller. Digital output displays will indicate fan speed in RPM and input power in watts for each fan. First, we'll run both fans at the top end of the PSC motor speed range, which is approximately 1720 RPM. This operating point and corresponding motor load will show the PSC motor at its peak efficiency. We will look at each unit separately, starting with the Vari-Green fan. As we zoom in on the display panel, take note that the fan speed is about 1720 RPM, and the power input reading is about 220 watts. Now let's take a look at the fan with the PSC motor. As we get a closer look at the display panel, we can observe that the fan speed has been matched at about 1720 RPM. Notice that this fan is consuming roughly 270 watts of power. Let's document these results and make an efficiency comparison. At the same fan speed and 1/4 horsepower operating load, the Vari-Green unit required 220 watts of power, and the PSC unit consumed 270 watts. With this information, we calculate the motor efficiency to be 85% for Vari-Green and 69% for the PSC motor. This means that the PSC motor consumed 23% more energy, and this is at its most efficient operating point. Now let's reduce the fan speeds by 30% and see what happens. As with the high-speed test, we'll observe the Vari-Green fan first. As the fan speed dial is turned, the fan speed immediately slows and will level out at about 1200 RPM. Notice that the value in the watts display is dropping too. As we reach our target speed, the input power is just 75 watts. The power decreased by 66%, as it should according to the fan's laws. Let's make the same speed adjustment to the PSC fan. As the fan speed slows down to the 1200 RPM target point, pay attention to the power input display. It isn't changing much. In fact, as the fan speed stabilizes near 1200 RPM, we can see that the input power is reading about 260 watts. This is only a 4% reduction compared to the high-speed power consumption of 270 watts. Again, let's document these results and look at efficiencies. The Vari-Green motor maintains its efficiency of 85% regardless of the fan speed and only needs 75 watts of power at 1200 RPM. However, the PSC motor consumed 260 watts, plummeting in efficiency to just 24%. In fact, the PSC motor is gobbling up nearly 3.5 times the energy. Such is the nature of the beast. As fan speed is reduced, a PSC motor converts an increasing amount of input power into heat, which incidentally leads to shortened motor life. For the final demonstration, let's really dial down the speed on the Vari-Green fan to around 20% of full speed. As the fan approaches 400 RPM, the Vari-Green motor consumes just 5 watts of power and runs quiet and cool, ideal for applications requiring broad speed ranges. As a summary, let's review our test data in a graphical format. As we observed, the PSC motor draws nearly the same power regardless of fan speed and has a recommended fan speed turn down of just 30%. The far superior Vari-Green motor is more efficient at high speed and offers dramatic energy savings as fan speed is reduced. Savings range from 20% to more than 70%, depending on fan speed. Plus, Vari-Green offers stable and cool operation down to 350 RPM. More speed flexibility, longer life, and much greater efficiency. Now that's Vari-Green.